Hello everyone. Now we'll start questions from 21 to 40. So the first question is given as sodium chloride when react with the sodium vapor to give a non-stoichiometric compound of this leads to what? So this is an interesting question. So suppose, wait a minute. Suppose this is a NaCl crystal, this and this. So we know that NaCl will form the FCC kind of lattice. So suppose this corner is occupied by chlorine kind of thing, and NaCl in the Na like this. Okay. So what happens when we treat the sodium chloride NaCl, this is in the solid state, plus NaCl in the gas phase. So what happens here in this crystal, the sodium will deposited on this surface, the sodium will deposited. After that, what happened? So after that, the sodium, the internal, this is suppose this is surface sodium. Okay, so the chlorine inside the cell will diffuse to the surface, and this sodium will convert to the Na plus electron, and this chlorine when diffused to the surface, it will generate a vacancy. This vacancy will be created, one kind of vacancy will be created in the crystal, and that vacancy will occupied by this electron. Okay, so the interstitial positions are occupied by electron, and this leads to the F center. Coming to the question number 22, the number of type of bond between the two carbon atom in the calcium carbide is. So basically calcium 2 plus and C2 2 minus kind of cation and anions are present in this compound. So what happens here, this C2, this is carbon, and this exists as a 2 minus state. Okay, now this is calcium, this is carbon, and this is carbon. Now this carbon 1 2 3, this is acetylide ion, acetylide anion. It is forming from the acetylene, triple bond CH. Okay, so that's why this is called a acetylide anion. And according to the question, the types of bond between two carbon atom, they are saying about asking about this bond. So in this bond, sigma bond 1 and pi bond is 2. So this is the answer B. Coming to the question number 23, which one of the following is the correct combination of the coordination number, geometry, and the hybridization? So 3 linear, not 3 does not represent linear, and 5 trigonal pyramidal, that can be possible, but sp3d2, this is octahedral, this is not possible. 4, that can be square planar, and sp2d, this is square planar, this is resemble, and this is tetrahedral. 3, that is 4, so it is also not possible. So correct answer is C. Next question 24, the correct order of the bond length in the above structure. Okay, so in this structure one can see that this is hydrajoic acid. In hydrajoic acid, this proton is acidic. This proton is acidic nature, so H plus and this is N3 minus, like this it will exist. So how the structure, this negative and N triple bond N plus, like this it will exist. So a correct order of the bond length in the above structure. So the first bond it has the, wait a minute, this bond, this sigma bond, that's the highest bond length, because this is easy to dissociate, so it has only sigma bond character, only sigma bond. So this is the longest bond, so the 1 is the longest bond, and between 2 and 3, so one can see here pi bond is 1 and here pi bond is 2. So accordingly, and another resonance structure also resemble this bond is the strong and short. So that's why the second bond length and then the third bond length. So correct option will be B. Now the question number 25, the spin only magnetic moment for the chromium CO6. So here the electronic configuration of the chromium CO6, the chromium in the 0 state. So the electronic configuration will be argon, this is 18, and 3d5 4s1. Okay, it's like this, and CO is strong field ligand. If we draw the orbital of chromium, it will like, this is d orbital, this is 3d, 1 2 3 4 5, and this is 4s, okay, like this. And in presence of strong field ligand, all the electrons are paired up and giving the final configuration 1 2 3 4 5, and this 1 2 3 4 5 6, like this, and 3p orbital, and it will form the D2sp3 hybridization. So that's why the number of unpaired electron is 0, and the spin only mu is, so magnetic moment is equals to root over of n into n plus 2 Bohr magneton, so that is equals to 0. So correct option will be D, the diamagnetic one. Okay, now the question number 26, which one of the following statement regarding the hydrogen is or are correct? So first of all, it acts as an ambidental ligand. That is not a correct option, because ambidental ligand is like this, N plus O minus double bond O. So in the ambidental ligand, this end can act as a ligand, and this end also acts as a ligand. So both will give the different structure. Okay, if we M N double bond O minus and plus, and another is that N double bond O, like this, two are different structure, so they are called the linkage isomers. So this is not possible. The hydrogen structure is NH2 NH2. Okay, both end are the same, and it acts as a monodental ligand. Is, yes, it can act as a monodental ligand or bidental ligand. Okay, as there is two lone pairs available. It acts as a bridging ligand. That is also true. Suppose this is metal and another metal, and this nitrogen and another nitrogen, this can act as a bridging ligand. So that is also possible. It does not bind with the metal. Not, this is a wrong statement, because it can bind with the metal. Now coming to the next question, question number 27. Which one of the following is the correct IP name for the compound is? So first of all, potassium, then there is a potassium, right? So this is a anionic part, so total charge about 2 minus, and this is the anionic ligand, and this is neutral, this is neutral. If there is a 2 minus charge, So chromium oxidation state X plus X minus 4, because 4 cyanide is present, is equals to minus 2, and X is equals to plus 2. So this is resemble the correct answer. We can determine this, and also by the nomenclature, this is according to alphabetical. This ammonia, after that the tetra cyano CEY, okay, tetracyanochromate. Okay, fine. Option B is the right answer. Now coming to the question number 28. The meridional isomer of coordination compound Ma3B3. Okay. So all A, B ligands arranged in the vertex of the planar hexagon. Suppose this is the hexagon. Okay, this is hexagon. This is central metal, and this is A. This is A. This is A. This is A. This is the meridional isomer. Okay, in the octahedral, both 3 atoms present in single plane. So all A and other B, here B, here B, here B. So all A and B ligand arranged at the vertices of a planar hexagon, that is not possible. And all A ligand on one plane, yes. All B ligand perpendicular plane of octahedral, yes, that's true, because this is one plane and another plane is this plane. Both are perpendicular to each other, so that's why this is the right statement. Okay, option B is the correct one. And third is that A and B ligand randomly arrange at the vertices, not at all. This is in the meridional isomer, this is the arrangement, and all A and B ligands are adjacent, occupying the vertices of a triangular face. This is example of the FAC isomer. Okay, in the FAC isomer, they form the triangle, facial triangle. So the option B is the correct. In the question number 29, the CONH3 cell 3, it is A3B3 example. This is FAC and MAR. Already I discussed this geometrical isomer, and I already discussed about the MAR meridional isomer. Coming to the FAC isomer, this is the central metal. Okay, and then octahedral kind of thing. This is A, this is A, and this is A, and this is V, this is V, and this is V. In this compound, this triangle, this is acts as a face. Okay, this is a face, so that's why this is kind of face, look like a face, and it is called a FAC isomer. And similarly, 3B boron B atom will form another face. So this is the FAC isomer. Coming to the question number 13, consider the following reaction. The reaction is given as the Nb2S5 5AgO, Nb2O5 5AgS. So in this question, on the basis of the relative electronegativity charges on the various ion, hard soft character. Okay, so here we will HSAB principle. Okay, so in this problem we know that this is soft, oxygen is hard, and sulfur is soft, and niobium is little bit hard. So what happened here, this is the soft, this is soft combination, and here the hard combination. So the product will be favored, and correct answer will be A. In the question number 31, which one of the following is correct regarding the addition of the acetic acid to the sulfuric acid, water and ammonia respectively? So acetic acid behaves as a base in sulfuric acid. That is true, because H2SO4 is the strong acid, then the CH3COH. So if we take the mixture of this, so this will act as an acid and this will act as a base. So this is a true statement. And weak acid in the water, we know that when we mix this with the water, it acts as a weak acid. Okay, and strong acid in ammonia, yes, that is also true, plus NaH3, it will drive the lone pair towards the proton, and this will generate the CH3CO minus plus NH4 plus. So this base will enhance the acidity of acetic acid. So that's why in the ammonia media it will act as a strong acid. Okay, so option A is the correct. Now the next question number 32. So what will happen if 1 molar of a solution of weak acid is diluted to 0.01 molar at the constant temperature? So according to the question, suppose a weak acid Aj will dissociate through the H plus plus A minus, and if we take initial concentration 1 molar diluted to this molar constant, so Ka. First of all, we see that Ka is concentration of H plus and concentration of A minus divided by concentration of Aj. So this is a constant. It is only the temperature dependent. So that is not true. Degree of ionization will increases. Alpha is equals to root over of Ka by C. As this is a constant, if the concentration is decreasing, so that the alpha will increases. So this is a correct statement. The pH will decrease by 2 unit. Let's discuss this. 2 unit. Let's see. pH 1 initially minus log concentration of H plus minus log 1 is equals to 0. Now pH 2 minus log of H plus, that is equals to minus log of 0.01, and this is equals to 10 to the power minus 2. So the thing will be the minus log 10 to the power minus 2. This will be 2 log 10, and log 10 is equals to 1. This is 2, and the pH will increases by 2 unit, not decreases. So that is not a true, and this will H plus concentration will decreases to 0.01 molar. Thing is that K is alpha square C. So alpha is equals to root over of K upon C. On the other hand, the concentration of H plus is equals to alpha C, not alpha square, alpha C. So this is equals to, by putting the value K by C into C. So here the value of this is 1 minus half of another, this will be half. So this is the power of concentration. So the final value will be K into C. Now the thing is that if the initial concentration is 1, first of all the concentration C1 is 1 molar, C2 is equals to 0.1 molar, just 10 to the power minus 2 molar. Then if we decreases the concentration, first of all the concentration of H plus first will be root over of K into 1, and in the second the H plus concentration 2 will be root over of K into root over of 10 to the power minus 2. So this value will result in a K root over of K into 1 by 10. Okay, so the H plus concentration will be 0.1 times, not the 0.01 times. So that's why this is also not a right answer. The correct answer will be B. And to the question number 33. So consider the following statement regarding the ionic product of the water, where CH and COH are the concentration of hydrogen and hydroxide ion of water respectively, and Kw is the ionic product of water. The value of Kw at 25 degrees centigrade is 10 to the minus 14. That is a true statement. We know that Kw is equals to 10 to the minus 14, and that is equals to K into Kb. Okay, so this is a correct statement. And C of H plus OH minus in the pure water, that is also true. Let's discuss about this statement. Kw increases with this H2O. This is the autoionization process. plus OH minus, and it is an endothermic process. So if the reactant temperature T1 and product temperature T2, then the T1 is greater than the T2. So according to the Lee Chatelier's principle, if we increases the temperature at equilibrium, the reaction will shift to the direction where the temperature will decreases. So if we increasing the temperature, reaction will shift to the product side. So we know that Kw is concentration of H plus into concentration of OH minus. If that is increases, so Kw also increases. So this is a correct statement. In this problem, we already know that Kw is concentration of H plus and concentration of OH minus. For pure water, the concentration of H plus is concentration of OH minus. So this is H plus whole square. Now this C of H plus is equals to root over of Kw. That is also a correct option. So correct option will be D. In the question number 34, an aqueous solution of contains 0.3 moles per liter, means molar solvent of KHSO4, and this 0.6 molar of the K2SO4. The pH of the solution will be, the pK value of this is this, and okay, fine. So this is weak acid and weak acid and it's salt. So it will follow the Henderson equation. So here the pH of the solution is equals to pKa plus log concentration of the salt by acid. So pKa given, the concentration also given, so pH will be 2 plus log of 0.6 divided by 0.3. This is 2 plus log 2. This is equals to 2 plus 0.3, 2.3. Correct answer will be A. The question number 35, which one of the following not acts as a buffer solution, a buffer in its aqueous solution? So this borax, is Na2 B4O7 form BOH whole 3, and this is a weak acid and its conjugate base BOH whole 4 minus, this is the conjugate base, so it will form the buffer, and NH4HF2 when this dissociates, it will form the NH4 plus HF2 minus. This is a weak base and this is a weak acid, actually conjugate base kind of thing. So it will also form the buffer because it can produce, it can supply the M minus, so that's why weak base. Buffer solution contains a weak acid and its conjugate base. In the CH3CONA, Na plus, so this is not a buffer solution, this is only the conjugate base is present, okay, so that's why. And if we take the solution of the ammonia plus ammonium chloride, it will generate the NH3, this is a weak base, plus this NH4 plus Cl minus, this is a conjugate acid, this is also form the buffer solution. Weak gas acid and its conjugate base, this is forming the buffer solution. Weak base and conjugate acid, that is also forming buffer solution. Only the acetate ion does not form the buffer solution. In the question number 36, which one of the correct, this is the Henderson, this is a simple, this is salt by base acid. Which of the following equation molarity? Molarity is that number of moles per volume in the liter. So 1000 moles, this is weight by molecular weight of the solution, and this is the correct answer. Now next question, question number 38. Despite of having obtained high purity, sodium thiosulfate is unstable as a primary standard. This is because in the first option, CO2 present in ordinary distilled water may decompose it. So the thing is that when this H2O plus CO2 is present, it will form the H2CO3. It will release the H plus. In presence of H plus, it will generate the H2SO3 plus sulfur. Okay, so that's why it will decompose. That's true. It can decompose by bacterial action. It's also true, because in presence of certain bacteria, it also decomposes. It decomposes upon the exposure of light. So this option is not an appropriate one according to me, because the action of light does not impact that much on the sodium thiosulfate. So 1, 2 option will be right. Now question number 39. A sharp endpoint not achieved during the titration of the boric acid against NaOH, the same endpoint can be observed. Okay, so boric acid is a weak acid and this is a strong base. Okay, by addition of the suitable Lewis acid to the solution. So basically sharp endpoint, this is kind of a sharp endpoint. Okay, so we have to obtain this when we are doing the titration. This is the volume of the NaOH and this is so the thing is that this is a weak acid, so kind of this, and for NaOH this will increase. So this is not a sharp ending point, basically sharp endpoint. So if we add the Lewis acid to the solution, it does not increase its acidity, so that is not a right solution. By using diphenylamine sulfuric indicator, no, that is not also the true. As the addition of suitable organic polyhydroxy compound, that is the true. Okay, when we add the polyhydroxy compound, this will add up to the OH and this form the chelate kind of compound. Okay, and plus H plus, it will release the proton. So more the acidity, more the sharp the end point. So the correct answer will be C. In the question number 40, which one of the following indicator not used as a acid base indicator? Okay, the methyl orange, this acts as a acid base indicator. Yes, the pH range about 3.1 to 4.4. In the phenolphthalein, this also acts as a acid base indicator. Its range about the 8.2 to 10. This is the pH range. And another is that methyl red, this is known. This is also a acid base indicator, and the pH range about this is 4.4 to 6.2 kind of thing. And the muraxide, I don't know about this. So we know that all three are the acid base indicators, so correct answer will be C.